go. And then this is your mic.
Yeah.
When you're ready. It is on, but June is going to introduce you.
Okay. Just using. I think it's.
But it's fine like that.
You don't want to.
No, I'm more used to this. It's fine. It's fine.
Good morning, everyone. Good morning. I hope you had a good night's sleep. The program continues today. And yeah, so we have lots of things to look forward to. So, ladies and gentlemen, it is my profound honor and immense pleasure to introduce a friend. Not just a friend, more importantly, a luminary in the field, a visionary whose contributions in the literature are nothing short of monumental, Raf Wouters. Raf is a senior advisor at the Research and Economics Department of the National Bank of Belgium. His work has consistently pushed the boundaries of our understanding, bringing new insights and innovative perspectives to the forefront of our discipline. His extensive research on the development and estimation of dynamic stochastic general equilibrium models has set new benchmarks in the field. These models have become indispensable tools for business cycle analysis and monetary policy analysis, profoundly influencing both academic research and practical policymaking. With decades of experience, Raf has published extensively, contributing to a deeper understanding of macroeconomic dynamics. His rigorous approach and relentless pursuit of excellence have earned him accolades and respect from peers around the world. His expertise in using macroeconomic models for policy advice in central banks is unparalleled, making his insights invaluable to both scholars and practitioners. For those interested in exploring his profile, a prolific body of work, I encourage you to visit his REPEC page. There you will find a comprehensive collection of his publications and his collaborations with distinguished co-authors from around the globe. Beyond his academic prowess, Raf is a beacon of integrity, a mentor to many, and a passionate advocate for the transformative power of knowledge. His commitment to fostering a collaborative and inclusive research environment has inspired a new generation of scholars who strive to emulate his dedication and intellectual curiosity. It is also important to note that Raf, despite his monumental achievements, remains a humble and reserved individual, known for his quiet demeanor and thoughtful approach. He speaks with a gentle, low voice that carries the weight of his profound insights. This modesty only amplifies the respect he commands in our community. Allow me to share a personal anecdote that perfectly encapsulates Raf's presence at the National Bank of Belgium. During a visit to the bank, I once asked a former colleague whether Raf was already in his office. Her reply was both humorous and telling. Every model has a constant term. Indeed, Raf's steady presence and unwavering dedication are constants we all rely on. Today we have the extraordinary privilege of hearing from this remarkable individual. He will be presenting a paper titled Fiscal Backing, Inflation, and US Business Cycles, a joint work with Frank Smets from the European Central Bank. This presentation promises to be a masterclass filled with the depth, rigor, and clarity that we have come to expect from his work. It is an opportunity to learn, to be inspired, and to witness firsthand the brilliance of a mind that has significantly shaped our understanding of macroeconomic policy and business cycles. Please join me in welcoming to the stage the incomparable Raf Wouters.
Is it on? Yeah. Thank you, Junior, for this introduction. Exaggerated, but anyway. Well, I always like to talk to you, and I learned a lot from all your work also, and well, from talking with you. So the respect is mutual. Thank you. So thanks for the opportunity to present this work here. So yeah, this is joint work with Frank Smets, and the usual disclaimer applies. So let's start with the motivation for this work. So in our original Smets-Wouters model, we basically assumed that the economy was functioning as a monetary-led regime, where the central bank is stabilizing inflation by responding to inflation, satisfying the Taylor principle. And fiscal policy is implicitly taking care of debt stabilization. Now, that policy, together with the assumption in the model that there are lump sum taxes, implies that fiscal policy is the way of fiscal policy is financed is neutral, and so we could drop that block from the model, and we only have government expenditure shocks that enter in the aggregate demand equation. Now that assumption was made maybe an acceptable approximation of the economy during the Great Moderation period, where monetary and fiscal policy were relatively stable. And but since then, and typically that period was thought of as a flexible inflation targeting regime that correspond with that setup. But since then, a lot happened. There was the great financial crisis that resulted in a period of zero lower bound, where the potential of monetary policy was constrained. The interest rate was restricted around zero, so that led probably to larger fiscal multipliers. A low interest rate, a low R minus G, also implies that there was more fiscal space, so more potential for fiscal policy. So that situation resulted in suggestions to have a combined monetary fiscal policy action to which and then during the pandemic a similar situation appeared, but then it resulted in a high inflation situation together with a higher debt ratio. So then there was a call for returns to the monetary policy setup. So that experience led to a lot of work on monetary fiscal policy setups in the models. Now, much of that work was based on extreme regimes, following the work of Lieber mainly, where you had either an active monetary policy set up, where monetary policy was satisfying the Taylor principle, monetary policy controls inflation, and fiscal policy does not matter. So that is the monetary regime. The other extreme is the fiscal-led regime, where Taylor principle is not satisfied, and no debt feedback in the fiscal rule, and so And in that situation, monetary policy is much less powerful, and fiscal policy is driving inflation. Now, typically, much of that work is in these extreme regimes or in a switching setup where there are possibility of stochastic switches between the two setups. We instead in this paper try to specify and estimate and also a setup that we could describe as an intermediate regime with partial fiscal backing. And so in this setup, fiscal policy will still commit to finance the debt by future surpluses to some extent, but it will maybe not take the full 100% of the burden of doing so. Monetary policy also will still try to control inflation, but to some extent it will have to accept inflationary consequences of partially unfunded government debt. So that is the objective. So we will present such a setup that we call intermediate monetary policy fiscal regime with partial fiscal backing. That degree of fiscal backing will be captured by a regime parameter lambda. In the baseline model, we will assume that lambda is constant across time and the same for all shocks, but it can be made time dependent, shock dependent, and I hope I will arrive at the last section where we do some first exercises to implement some work in that direction. And so, yeah, we will basically, after explaining the methodology, I will present some estimation results with a Smith-Wouters model with that partial fiscal backing setup. That will allow us to say something about the average degree of fiscal backing, how this partial fiscal backing affects the transmission of various shocks in the economy, how these then affect the drivers of inflation, and we will also do some simple exercise to evaluate. The estimation will end before the COVID period, but we will do a simulation exercise for the more recent period of increased inflation. The literature, I think I can be quick on this side. There is on the theoretical side, the seminal work on the fiscal theory of the price level, of course. There is also work on what that setup implies for the monetary policy and optimal monetary policy. We will, in this paper, we will not talk about that. But a paper that is very important for our work is the work by Pianghi, Fascini, and Melossi, where they present basically the methodology that we also apply in this paper. Empirical literature that is related to our work, there is this regime switching work in the literature. There is more recently with the high inflation also papers that stress the fiscal origin of this high inflation. And then there is an empirical literature on how the monetary policy rule is important for the fiscal multiplier. There is also literature where the role of the fiscal policy reaction function is shown to be important for the monetary transmission network. And so, yeah, all these findings, I think, can be incorporated in our setup. So the methodology. we start here with a very simple setup. So the basic Fisherian model that I think was first presented by Lieber. So this is a very simple setup with an endowment economy, with flexible prices and one period government debt. Supply is fixed, so there is no supply equation. The IS curve reduces in this setup to the Fisher equation with a constant real rate. There is a government budget constraint with a one period debt. So these are all, we only consider linearized expressions in the paper. So government debt here in this setup is just a function of the short-term real interest rate. And tau is the primary surplus. And then we have a reaction function for monetary policy. Very basic, psi is the reaction coefficient to inflation. And tau, the reaction coefficient for fiscal policy, is basically described by the delta B, the reaction coefficient to the debt. Combining 1 and 3, we find this dynamic equation for inflation. 2 and 4 results in the government debt equation. And so we have a system of two state equations, 2 state variables, one forward-looking, one backward-looking. So we know the stability conditions. We must have one root bigger than 1 and one root smaller than 1. And so we can have 2 situations. Either psi is larger than 1, and then the coefficient delta B, the stabilization coefficient for fiscal policy, must also be sufficiently high, or either psi is smaller than 1, and then delta B should be sufficiently small. So if you look what this implies for, there is only one shock here, the shock to the primary surplus, so an expansionary fiscal policy shock, first in the monetary-led regime. So we see that a deficit, this is just an IID deficit shock, is in this setup completely financed by future surpluses in public sector, and inflation is basically insulated. And so the stabilization of debt is completely implied by the primary surpluses in the future. So this is a completely funded fiscal shock. The other setup, the other possibility is a situation where the fiscal expansion impact is completely stabilized by an increase in inflation. That increase in inflation leads to a negative real interest rate that stabilizes the government debt. So these are the 2 extreme situations that can happen in this simple setup. Now, what Bianchi, Fascini, and Melossi do in their paper is implementing these 2 shocks within one model. And the way that they do that is by including 2 types of shocks in the fiscal reaction function. There is epsilon m and epsilon f. Epsilon m is the completely funded shock, monetary-led regime. Epsilon f is the unfunded fiscal shock. And so the way that they implement that is by formulating a shadow economy. And in the shadow economy, only the unfunded shocks are active. They determine the evolution of inflation and debt in the unfunded, for the unfunded shocks. And then the reaction function in the real economy is specified in terms of the total debt in deviation from the fiscal unfunded debt, and the same for inflation. Inflation, the reaction function of the central bank is defined in terms of inflation and deviation from this fiscal inflation driven by the unfunded shocks. And so this model, they can estimate it on the data, and the data will identify which type of fiscal shock is the most effective to explain the data. And they, in their exercise, they typically find that in the late 60s, early 70s, there were important transfer shocks that were unfunded, very persistent shocks that had relative large effects on inflation, and that can, in fact, in their approach, explain most of the increase in inflation in the early 70s then. So, yeah, this is just the summary that they have these two types of shocks together in one model setup. So what we instead do is defining shocks with a partial fiscal funding. And so if we follow their setup, we define the funded shocks as a function lambda, a fraction lambda of the transfer shock, and the other fraction, the remaining fraction, 1 minus lambda, is the unfunded shock. And so for the rest, we follow the same structure with the shadow block. In the shadow block, the unfunded shock is active. That determines inflation and the debt that enter into the policy function. And so we have the possibility to have a complete range of impulse responses depending on the lambda. And so if the lambda is 1, we are back in the fiscal funded shock, the blue line. If lambda is close to 0, we have the typical unfunded fiscal shock. So that is basically the methodology that we apply. Now, there is a second difference with the Bianchi paper, and that is that they only consider this possibility for the transfer, the fiscal transfer shocks. Now, in reality, primary surplus of the government sector is driven by all types of shocks. All shocks have fiscal implications, and so it depends on how these fiscal implications are then financed, funded or unfunded. And so we apply this lambda not only to the transfer shocks, but to all shocks that enter into our model. And so to illustrate how this lambda then, the degree of fiscal backing affects the impulse responses, we can look to a still relative simple model, new Keynesian model here, with 4 types of shocks. We will have an aggregate demand shock in the IS curve. So we epsilon d enters into the aggregate demand equation. We have a productivity or a potential output shock in the Phillips curve. So here we have sticky prices. We will have long-term debt with declining coupon rate, so that results in this simple holding period return expression for the long-term bond, depending on the maturity. This results then in government budget constraint that depends on the holding period return of the long-term bond, the growth rate, the ratio of public debt and the inflation rate. And we have then again this transfer shock. So we can look now at okay, so in the model we have extended with the reaction functions, and these are the reaction functions for the real economy. So they are again specified in terms of interest rate reacts to inflation in deviation from this fiscal inflation, output gap in deviation from the fiscal output gap, and then these are the reaction coefficients in the fiscal regime if they are not zero, and they, in the previous setup we simplified and these coefficients were zero, but here they appear. And again, for the fiscal rule, the reaction function of fiscal policy is specified in terms of debt in deviation from this unbacked fiscal debt, and these F concepts are then determined in the shadow fiscal block. Yeah, sorry that it's not, the figures do not appear very clear, but I hope I will be able to explain the message. So again, this is a transfer shock, same shock that we looked before, and now for different values of lambda. So if we start with lambda close to 1, so then we are in the standard monetary-led regime, fully backed transfer shocks. We see that there is relative little or no effect on inflation and on output. It results in a large deficit that is then financed in the future by large surpluses, and that determines the stabilization of the debt ratio in the long term. So this was the standard setup of transfer shocks in Raf-Wouters type of model. If we then increase, look at the cases where lambda is higher, and so part of the transfer shock is unbacked by future surpluses, we see that there starts to be some effect on inflation, an effect on inflation that is not offset by a strong interest rate reaction, so the real rate declines, that stimulates output, so there is some financing of the transfer expenditure by the automatic income stabilizer of the government sector, and so future surpluses has to be less, and the debt is stabilized by a mixture of future surpluses and inflation effects. And we can go towards high, lower and lower lambdas to have less and less funding. So that is the effect of the transfer shock is comparable to what we have seen before, but here in a more dynamic setup. I don't know what happens that they appear clear for a moment, but so here more interesting now in this setup is the impact of a negative productivity shock or a negative potential output shock. So again, we can start from the situation where lambda is close to 1, fully backed fiscal implications. Negative productivity shock leads to higher inflation. Decline in output leads to a primary deficit and debt. Debt is then stabilized by future surpluses again. If we decline lambda, only partial fiscal funding, we see that the impact on inflation is gradually increasing. That increase in inflation is not offset by an aggressive interest rate, so the real interest rate declines, and that supports output. That leads to some extent to the financing of the. There is an alternative way to look at this transmission mechanism, and the fact that there is only partial fiscal backing means that fiscal debt starts to be considered as part of net worth. An increase in net worth leads then to higher consumption, and that leads to higher inflation. So there are always various sides in this general equilibrium setting to look at the transmission mechanism of the shocks. And so in the extreme case, we can have that for a negative productivity shock. Output starts to increase comparable to what people have observed for a zero lower bound situation, where the sign of the output effects from supply shocks could be changed. Also interesting is a monetary policy shock. Again, the blue one is the one with full fiscal backing. So monetary policy shock leads to a decline in inflation and a decline in output. If there is now only partial fiscal backing, we see that because there are deficits, increase in debt, there starts to be more inflationary effects over time. And so we observe this, what seems called the stepping on the rake effect, where a restrictive monetary policy on impact leads to a potential increase in inflation over the longer period, which illustrates the problems of monetary policy to control inflation once you move to a situation of unbacked fiscal debt. The demand shock, well, here, because this is a positive demand shock, positive surpluses, so there is less, lower inflation and somewhat higher output in that setup, but the effects are less important. So that explains the intuition, and so we can now go to the estimation of the full Raf-Wouters model with partial backing. So we extend the model with a fiscal block. It's important to understand how fiscal deficits and the different fiscal variables, income, expenditure, transfers, depend on the business cycle to make the interaction between the business cycle and public finance realistic. So we extend the model with equations for taxes, transfers, government spending, and a budget constraint. We add some observables. We add the market value of government debt, primary surplus, growth rate in transfers and government spending. And we have for shocks, lump sum tax shock, lump sum transfer shock, government spending, and some residual debt shock to satisfy the budget constraints. We also include a one-year interest rate to handle the zero lower bound effects, and we have, of course, to add this shadow fiscal block in order to evaluate the impact of the unfunded fraction of the shocks in this shadow block that feedback then through the policy reaction functions. So these are then the estimation outcomes over the period 65-19, when we stopped before the COVID crisis. So the crucial result, of course, is the estimates of lambda in this intermediate case, and we find a lambda of 83. So there is some, and if you look at the confidence bound, it's significant below. We use a uniform prior, so the bounds are significant below 1 in the intermediate regime. So there is partial fiscal backing. We also consider at the extreme cases where we fix lambda to 1, the standard model, and the pure fiscal let regime then where lambda is equal to 0. If you look at the marginal likelihood, we see that the intermediate regime, the slightly better than, well, significantly better than the monetary let regime. The pure fiscal let regime clearly is not resulting in a good fit to the data. So that is the first important result, that there is significant evidence of this partial fiscal backing over this period. If you look at the coefficient, there are some interesting effects. So we see that as the degree of fiscal backing declines, we see that there is evidence of increased nominal stickiness So nominal stickiness helps to smooth the effects of the fiscal channel on inflation over time. Also on the real rigidities, especially if we move to the extreme case of a fiscal-led regime, we see that all the real rigidities also increases the same logic to reduce the effects, the inflationary effects on the real decisions. Also interesting is to see that the maturity estimates in all the models are relatively low, but in the intermediate regime we find a 0.9, which I think corresponds with more or less 3 years maturity, which is somewhere in the average. And there was I think in the US a decline in maturity over the 80s and then an increase again. We have a constant parameter here, so recently the maturity is longer, but a large part of the long duration is held by the central bank, I think, which also in our setup, the transfer shocks are the most persistent shocks, and so that goes in also in the direction of what Bianchi found, that there was important evidence in the transfer shocks for these inflationary fiscal inflation effects. Okay, we can then look at a decomposition, a historical decomposition of the inflation is the most important variable here. And so in this figure, the blue part is the effect of the funded shocks, and the red effect is the effect of the unfunded share of the shocks. And so we see that in the 70s, well, the dominant inflation trend is explained by the funded shocks. But in the 70s and also recently, there is some effect from some significant effect from the unfunded shocks. Important in the period since after the financial crisis, the fiscal inflation to some extent helped inflation to decline more and maybe to fall into a Japanese type of deflationary situation. So that is interesting to observe. The impact on the primary surplus is somewhat more complicated to explain, but it basically shows the fiscal space, the income effects from the unfunded shocks, how they contributed to fiscal receipts. And, so what shocks are driving these variables then? And it's interesting to have a look at the unfunded primary balance, for instance, which is, or the complete primary balance. The fiscal shocks are clearly not the only variable that drive the primary surpluses. The primary surpluses are largely endogenous, and that is why it is important to apply this lambda also to this type of shocks, and that there can potentially be important effects on the transmission of these shocks. And for inflation, we see then that the unfunded part, the red part of the decomposition here, is also not 30% comes from the fiscal shocks, but 56% comes from the supply shocks. So the inflation, the fiscal inflation in the 70s there was to some extent driven by negative supply shocks that led then to this fiscal inflation effects to rise in inflation. Well, this is basically confirming the same findings that fiscal and the supply shocks were the dominant drivers of inflation. let's then look at how this fiscal channel affects the transmission mechanism of the shocks in the model. So this is again the shock for the public transfers. So the dotted or the dashed line here is the impact of the unfunded shock, and the full black line is the full effect in the actual economy. So we see here that for the public transfer shocks, the complete effect in the actual economy comes from the unfunded fraction of the transfer shock, which is logical. Smith-Wouters transfer shocks are neutral. It's only through the fiscal channel that they start to affect inflation, and so the complete effect here comes from. And these are significant effects from the transfer shocks. More interesting then is to look at the supply shock. So here, maybe let's first look at the TFP shock. So we have here a positive TFP shock, and we see that a large fraction of the total effect comes from the fiscal channel, fiscal inflation effects. It's a positive TFP shock that leads to a primary surplus and debt. So there is primary surplus and a decline in debt. So there is a lower pressure on inflation that leads then to some declining effects on aggregate demand. So clearly this fiscal channel has an important effect on the transmission mechanism of the TFP shock. The same applies for price markup shock. So here too we see that the fraction of the unfunded fiscal effects are important, and especially for output changing to some extent the magnitude of the output effect. For monetary policy, on the other hand, we see relative little effect. So the fiscal channel here for inflation and output, they remain very small for the estimated fraction of the... And the same applies for our crucial demand shock, risk premium shock. Here too, the dashed effects on inflation and output are relative minor. So the main effect is on public spending shocks and on the supply shocks that we find an effect. Okay, so we can then also do an exercise for the recent period after the COVID. To do that, we add some ad hoc shocks to capture the impact of the COVID shock itself, but the fundamental shocks remain active and give a relative realistic effect. We are especially interested to see how this fiscal channel is active given the huge deficits during this period. And so if you look at the fiscal inflation, we see the black line is the impact of the fiscal expansion. The scale is not visible here, but I think that the fiscal shock here explains about 2% of the rise in inflation. But there are also, through this fiscal channel, effects from the supply shocks and aggregate demand. And so if you look then at the complete decomposition of inflation, we see that there is an important effect of the fiscal inflation, but that peaks earlier than the actual peak in inflation itself. So the actual peak in inflation was still mainly driven by the supply shocks. Basically the fiscal inflation was offsetting the negative effects from the demand shocks that were the private demand shocks that were active during that period. Okay, so let me skip for a moment this conclusions and go to some follow-up work and especially the exercise where we try to evaluate the time variation in lambda. We did several extensions to evaluate to what extent lambda is shock dependent or time dependent. A simple first exercise is to have lambdas that are shock specific. The result there is not showing much evidence of differences across shocks. So we do different things. We either have a setup where we have a lambda for the fiscal shocks and a lambda for the non-fiscal shocks. They turn out to be not significant different, and even slightly higher lambda for the fiscal shocks than for the non-fiscal shocks. Also, if we try to estimate lambda really shock specific, there are not much evidence of strong deviations between lambdas over shocks. Then we evaluate, or we try to do some robustness exercises for the time variation. First simple exercise is to do subperiods estimation. In that case, we find lambdas that are slightly smaller over the two periods than the 83. But they are equivalent over the two periods. And in that case, there are also some interesting changes in the parameters over time, but they go in the same direction as what we documented in the original, in our original paper. So then, and that is where I look forward to your reactions and your interpretation. We do some regime switching setups using Junior's toolbox. And the first exercise that we do is to consider two models with lambda either fixed to 75 or 90, so symmetrically around the 83 that we estimate. We also do the more extreme case where we have lambda fixed to 0 and 1. So in the first exercise, we have a marginal likelihood that is very similar to the baseline fixed model, which suggests that there is not much evidence in the data for time variation, I would tend to say. But if we then look at the regime probabilities, it's not very clear. There are significant bounds. I don't see them very clear. There are bounds around this regime probability. So the regime 1 is the low 0.7 lambda. Regime 1 is the high lambda. So this is the probability of regime 1. And so we see that what you would expect is that in the 70s there was some evidence in the data for a lower lambda, so more a stronger fiscal channel. But on average, the two regimes have a probability, and there is also some cyclical effects in the probability of the two regimes. And if you see in the bound, it is here. It remains slightly higher during the zero lower bound to more evidence of a higher lambda. If we look at this regime probability in the extreme case of a 0,1 lambda, we see that the monetary regime gets, this is again the probability of regime 1 with lambda 0. So in normal times, the monetary-led regime is the dominant one, and it's only during shorter periods in the 70s, and then more recently after the zero lower bound, that there is a probability, significant probability of being in the fiscal-led regime. But here the two models are much more extreme, and I'm struggling a little bit with the interpretation. Is this now strong evidence for time variation in the landas or not? The marginal likelihood suggests to me that there is not that strong evidence. The significance of the bound, they illustrate some intuitive acceptable variation. So it's a little bit a mixed result, I think. We also did an exercise where we have two types of shocks, pure funded shocks and unfunded shocks for each type of shock. So we have a productivity shock that is either fully backed or a productivity shock that is fully unbacked. And we have a lambda there that captures the relative standard deviation of the shocks. And so again, we find a value of close to around 0.8. So 80% of the standard deviation or the standard deviation of the funded shocks, or 80% of the standard deviation of the unfunded shocks. So the unfunded shocks are smaller than the funded shocks. And in that case, this is a very flexible setup, in fact, which captures both time variation and shock dependence. And in that case, we find an improvement in the marginal likelihood. So that suggests that there is evidence that this fiscal backing is changing through time and over shocks over time for specific events. But it's a more complex dynamics that is then imposed. Another question in terms of, and this is the last exercise that I will show, is whether these fiscal effects really comes from the unbacked debt mechanism, and whether that mechanism would survive if we have a model that has already a stronger impact of fiscal shocks on the economy. And so we do two exercises. We have an exercise where we have a fraction of the household that is liquidity constrained. That is to capture the impact of the transfer shocks mainly. An alternative exercise is where we have complementarity between private and public consumption, and that can then explain a different transmission of the government spending shock. In both setups, the lambda remains unaffected. So clearly, the fiscal channel that we are introducing here is, I think, stronger. It applies to more shocks, and it is more persistent than the effects of these specific extensions of the model. So, okay, that was most of the results that I had to show. So, thank you.
As expected, Raf did not disappoint. Questions?
Well, I was working on similar things for a number of years and with different models. And I have some number of kind of comments, or maybe, one of the things which I understood from the paper, that you have one period debt. And is it right? So you have one period. Yeah.
We started with this very simple setup. Sorry. We started with this very simple setup to illustrate the mechanism, and there we assumed one period debt. But in the actual model that we estimate, we estimate a maturity. of the public debt. And the estimated maturity was on average 3 years of debt.
Because we were taking it from the data of about 5 years, so I don't know if maybe it's
but
more contemporary.
In the data, it's time varying.
Okay.
It's highly time varying. In the 80s, it goes below 3, and then recently it is indeed 5, 6 years. But a large fraction now of this long public debt is held by the central bank, so that reduces the duration of or the maturity of the debt held by the private sector, probably.
So that was my kind of comment to figure out what happens. Another thing what I probably missed is whether your tax is, because you have a tax, and is it distortionary tax or is it lump sum tax, or whether it has inflationary effect on its own. And
the tax is a lump sum tax, so it's
okay.
Yeah.
Then I just, we can talk about it later, but I can say that we were doing simplest possible model of monetary and fiscal policy interactions. So you have your own model, which is relatively elaborate. We had a kind of down to Phillips curve and Euler equation, more or less, but we had interaction, dynamic optimal interaction of optimal monetary and fiscal policies. And we did the forecast for inflation up to 26, and basically inflation would go up as it did, and then it would go down and become persistent and remaining by about 1.5% above the target by 26. And out of this 1.5% is actually 1% was due to COVID era shocks, which is probably the same what you have in your results, which is quite nice. And 0.5% was associated with Biden stimulus. So the effects were staying, it was quite big relative of that, but supply shock dominated. And another thing which I want to say by reacting on your...
In your setups, do you have this fiscal channel also for the non-fiscal shocks?
We have shocks. We have government expenditures and transfer shocks, and we have the taxes are distortionary, so they have their own inflationary effect. Well, we can talk. It's just in a very different thing. You have pretty much.
My impression is that the magnitude points in the same direction. We should maybe have a longer simulation to check how this inflation, what is the persistence of these inflation effects, because you talk about 26, so that would be interesting to check whether we also have this persistence.
And one kind of sentiment when you showed the picture of not really switching thing, but wobbling around 0.5%, I would say, well, I wasn't using Junior Toolbox. I was using my own code and different model representation, not three matrices, but whatever. So it's kind of potentially slightly different. But what I say is we also looked at all possible, fiscal, what people did find when they do fiscal policy switches, and everyone does different assumptions and all goes all over the place. And unlike, I think, monetary policy rules, which gives you clear switches pretty much, I think fiscal, a lot of it wobbles in the middle, and it's up to your interpretation what basically deal with it and how to modify. So you're not unique in not knowing what the hell is going on. So, okay, that's all.
Okay, thank you.
Raise your hand so that I can see you.
Hello. Thanks, Raf. Very, very interesting. It's unfortunate I should have read this probably last night. But there's a few little things that I'm just struggling to, would like, if you can clarify. So in this, so I firstly agree about the non-distortionary taxes and lump sum. That's always a big thing that pops up. And it's not clear to me how important that would be once the endogenized taxes in the Smets-Wouters model. So there's no arbitrage condition that, so you have this, I found the paper now online and I went quickly through it, where R gross R is now has to equate with the expectation of the bonds. I think you had that equation in your slides as well, where this long-term bonds as long-term bond rate is a function of the coupons, but this must equate in a no arbitrage condition, and this seems like it's effectively what's creating the link between that no arbitrage condition. So there's this link that's happening here, and if you look at the forward-looking IS curve, that's related to gross R, and in the government intertemporal budget constraint, you have this RB, and then that's tightly linked in that equation. Now that's an expectation, right? And then R is going to have its own Taylor rule, and sorry, this is quite long. And then you have the shadow economy Taylor rule as well. That's also separate. So it's hard. I'm not fully. So it's a bit different from the usual fiscal theory of the price level setup, like you showed in the simple example, in this like toy model that you showed first. So I'm just struggling to see the mechanism here where the fiscal inflationary effect is coming in, where, if I remember correctly, in like Lipa's model, the price level needs to adjust to, and you showed it in your first graph, right? In that active fiscal policy, passive monetary policy, you see the price level have to jump, or the inflation jump, to clear debt. So I'm trying to hone in on that no arbitrage condition, and if you can just help me understand this mechanism that's linking the shadow economy dynamics to this dynamic.
I didn't show the shadow block, but so in the shadow economy, only the unfunded shocks are active, and there is a monetary policy and a fiscal policy rule that is of the same structure, the same role, but only then this effect and this effect. So there is a coefficient to the fiscal inflation and the output gap, and the same for the public debt. There is a reaction coefficient to that fraction of the debt in the fiscal block. This block captures what you have in mind with the fiscal theory mechanism. They determine the inflation outcome necessary to stabilize that fraction of the debt. And so in the actual economy then, there is a more complicated reaction function that has both these components. But basically, the interpretation is that in the reaction function, there is this trend inflation. In this case, it is the fiscal driven inflation trend. Remember, not in our 2007 paper, but in earlier work, we had an exogenous fiscal trend that was driven by an own independent target shock. So here, in fact, what we have is one interpretation of this fiscal target shock that explains then the long-term trend, but here it is completely driven by the fiscal implications of the unbacked shock.
It's very much reliant on the calibration, because the intertemporal budget constraint in the one that you showed us is just pi, normal pi. In the shadow economy, it's not pi, it's pi f, and it must stabilize debt. So there's debt's flat in that example, in that shadow economy. So you work out what the inflation is.
Their debt is affected by the unbacked fraction of the shocks. So there are fiscal implications, there are impacts on the deficit, on the debt accumulation, and there is then the expected inflationary and real interest rate responses that are expected to that fraction of the shocks, and that work out completely consistent in that block.
Thank you. Your presentation really hit the right spot of my nerve, but I will just ask you 3 questions. Actually, I have many. What is your view that the strategy that Bianchi and all they use the shadow economy to capture the unbacked debt? As I understand, they have a parallel model which they call the shadow economy, right? So the lambda captures the unbacked amount debt. What is the intuition behind this? That's my first question. Second question is also general. So in your model, your surplus basically is tax minus transfers, right? So when you have an increase in transfers, you don't have government expenditure. So when surplus goes down initially, that means tax will also need to go down. So sometimes people will always argue why you only report surplus, while surplus by definition is the difference between tax revenue minus government expenditure. So how do we handle that? My last question would be, when you estimate your own Raf Wouters model, you mentioned that you showed us the lambda for regime M, you have lambda equals to 1. For regime F, I think it's 0. And for your so-called intermediate model, you have lambda equal to 0.83. I would just want to know, when you estimate your model, do you also put restrictions on those policy reaction parameters in fiscal and monetary policy rule, such that the conditions for regime M, F, and intermediate regime are satisfied respectively, or you don't put restrictions on those parameters? Thank you.
Many questions. The first one, I think, was in terms of interpretation of the mechanism. Well, and I think it's basically interpretation of the reaction functions, no? And there, yeah, it is what I would repeat what I said before. In many models, the policy function is defined as a reaction to inflation, but inflation in deviation from some trend target. But that trend target is often modeled as an exogenous process. So the way to look at these reaction functions is to say, well, this trend inflation is related to the fiscal implications of partial funding, fiscal effects. So that I think is one interpretation of the results and the inflation channel that is present in the model. Your last question was about the mechanism. So you have to, in the shadow block, basically the shadow block is stabilized based on the hypothesis that there are fiscal shocks that are unbacked, and that the monetary policy reaction does not satisfy the Taylor principle for that fraction of the shocks. And so the stabilization of the economy comes via inflation that is stabilizing debt. For that fraction of the shock in the shadow block, that is the mechanism that is active. For the fiscally funded shocks, the standard dynamic mechanisms of the monetary-led regime is active. So you have really these two mechanisms active in the same model. For a fraction, lambda, you have the monetary-led logic that is active and stabilizing the economy. For 1 minus lambda, it is the fiscal theory that determines the dynamics of the shocks. So both are active and stabilize the overall setup.
So we are over time. Thank you very much, Raf. Please, unless...
Yeah, we have online questions, but if there's time, we can get to some.
One, is it a short question?
No, we can do one. Thank you. Hi, thank you, Prof. So we have a few questions online, but given the time constraints, let me just choose one. Why does government budget include exogenous discount factor beta?
I'm not sure can you repeat the question?
Sorry, sure. Okay. Why does the government budget include exogenous discounting factor beta?
Probably it is a question to this. That follows immediately from the linearization of the budget. I think it's standard to have that coefficient. So yeah.
Okay, thank you.
So please join me in thanking Raf.